Imagine an island, isolated from the rest of the world, where 100 brilliant logicians have been imprisoned by a mad dictator. Each of these logicians is highly intelligent, perfectly logical, and knows that all the others are just as logical as themselves. The dictator, with a twisted sense of humor, has devised a puzzle that is their only hope for freedom. Each prisoner is assigned a cell, and every morning they are all gathered together in a central hall. On each person's forehead, the dictator paints a single dot, either green or blue. The catch? No one can see their own dot, but everyone else's is visible. There are no mirrors, no reflective surfaces, and no way to communicate or signal to each other. The rules are simple. Every night, each prisoner has the opportunity to step forward and declare, with absolute certainty, the color of the dot on their own forehead. If they are correct, they will be freed. If they are wrong, the consequences are dire. The dictator announces one more crucial detail. At least one person on the island has a green dot. The question that hangs in the air is deceptively simple. Can anyone figure out the color of their own dot? And if so, how? At first glance, the puzzle seems impossible. After all, each person can only see others' dots, never their own. How could they ever be certain about their own fate? But as the days pass and the logicians think, a fascinating pattern emerges, built entirely on logic and the power of common knowledge. Let's start with the simplest scenario. Suppose there is only one prisoner on the island. The dictator's announcement that at least one person has a green dot means that the lone prisoner, unable to see anyone else, must conclude that they themselves must have the green dot. On the first night, they step forward and declare, "My dot is green," and earn their freedom. Now let's imagine there are two prisoners. Each sees the other's forehead, and let's say both have green dots. On the first day, each sees one green dot but doesn't know their own. If one of them had a blue dot, the other would see only one green dot and, thinking they might be the only one, would have stepped forward on the first night. But when neither steps forward after the first night, both realize, if I had a blue dot, the other would have seen only one green dot and would have left. Since they didn't, I must also have a green dot. On the second night, both step forward, declare their dots are green, and are freed together. This pattern continues. If there are three prisoners, each with a green dot, each sees two green dots. On the first night, no one steps forward, because each is waiting to see if the other two will go, as in the two-person case. When no one leaves after the second night, each realizes, if I had a blue dot, the other two would have each seen only one green dot and would have left on the second night. Since neither did, I must also have a green dot. On the third night, all three step forward. The logic scales up beautifully. With n prisoners, all with green dots, each sees n1 green dots and waits. Each night that passes without anyone stepping forward, they gather more information. Specifically, they learn that there must be more green dots than they can see, because if there were fewer, the others would have already left. After n nights, all n prisoners step forward, confident in their deduction. But what if some prisoners have blue dots? Let's say there are 100 prisoners, and 98 of them have green dots, while 2 have blue. Each green-eyed prisoner sees 97 green dots and 2 blue dots. Each blue-eyed prisoner sees 98 green dots and 1 blue dot. The blue-eyed prisoners, seeing so many green dots, wait, because they cannot be sure of their own status. The green-eyed prisoners, meanwhile, are waiting to see how many nights it takes for the group to act. The crucial point is that only the green-eyed prisoners will step forward, and they will do so on the 98th night, after confirming through logical deduction that they must also have green dots. This puzzle is a brilliant demonstration of common knowledge. The idea that not only do you know something, but you know that everyone else knows it, and everyone knows that everyone knows it, and so on. The dictator's announcement that at least one person has a green dot is what sparks this chain reaction of reasoning. Without it, the prisoners would never be able to deduce anything about their own dots. The green-eyed puzzle is more than just a test of logic. It's a window into the way information spreads and builds in a group, even without direct communication. It shows the power of shared understanding and how, Even in the most constrained circumstances, logic can lead to liberation. So, the next time you encounter a seemingly impossible challenge, remember the green-eyed logicians. Sometimes, the key to solving the hardest puzzles lies not in what you know, but in what you know about what everyone else knows. The answer, hidden in plain sight, just needs the right spark to set the chain of logic in motion.